Today's lesson is the first lesson of Unit 2. So it is Unit 2, Lesson 1, Graphs as Solution Sets. And our objective is students will be able to identify solutions of a curve. So let's start this off with our vocabulary word, which is actually a word that you've already heard before. The word is solution. Solutions are values that satisfy an equation. And in the past when we've looked at solutions, let's say we've been doing 2x plus 7 equals 13. The solution of this would be x equals 3, because 3 is the only number that we could put in place of x. Well, now we're going to be looking at equations that have more than one variable. So these equations would have x and they would also have y. So when we're looking at curves today, and a curve could be a straight line or it could be a line that has a curve in it, the solution of a curve is the ordered pair x, y. So if you think about graphs, the ordered pair x, y would be a specific point on a graph. So we would be looking for a specific point on a graph or a specific point on a curve. The second point we want to emphasize today is that a curve has an infinite amount of solutions. So when you draw a line or a curve, you always have to put the arrows on the end showing that this curve goes on forever. Well, if the curve goes on forever, then that means the coordinates x, y, or all the ordered pairs that fall on that curve also go on forever. So we have an infinite amount of solutions on a curve. Next, let's move on to identify solutions from a graph. Our first example is negative 3x plus y equals negative 2. Now the first thing I want to do is solve this equation for y, or I want to get it in slope-intercept form, y equals mx plus b. The reason why we want to do this is that we've learned how to graph equations when they are in the form of y equals mx plus b. So it just makes sense to convert it to the form that we use for graphing. Last step, I'm just going to rearrange so that we start with a positive 3x and then we have that negative 2 or minus 2. My next step is to actually take this equation, y equals 3x minus 2, and to graph the equation. So let's go on to another page with a coordinate plane. And we are going to graph that equation of y equals 3x minus 2. So quick reminder, we start down at the y-intercept. Our y-intercept here is negative 2. Then we use our slope. The slope was 3, or 3 over 1. And we rise up 3 over 1. Up 3 over 1. And I have told you that I want you to plot at least 3 points when you are graphing a line. Make sure we always remember to put those arrows on the ends, showing that these lines go on forever. So step number 2 was to graph the curve. Step number 3 is going to be to identify 3 solutions. And my 3 solutions are 3 points that the line or the curve passes through. So when we look at this line, we've actually already identified 3 points. We have this first point, our y-intercept, at 0, negative 2. Our second point that we found using slope is up at 1, 1. And our third point up here is at 2, 4. 1, 2, 3, 4. Yeah, 2, 4. Remember, we can have an infinite amount of solutions. So if we continued on this slope of going up 3 over 1, up 3 over 1, we would continue finding points that fall on this line. We could also go down 3 over 1, down 3 over 1. Any of these points would be considered a solution. So these three that I identified aren't necessarily the only answers. They should be right answers, but there's an infinite amount of solutions we could come up with. So the last thing I need to do is prove my solutions are true. Basically, we are just checking our work. And we can do that by substituting the 3 points we identified into the equation that we have. So we're going to be substituting 0, -2, 1, 1, and 2, 4 all into this equation that we started out with up here, the -3x plus y equals -2. So I will walk through that process slowly with the first one, and you can follow along. My equation is -3x plus y equals -2. With my first point, x is a 0, so we're going to substitute 0 in place of there, and y is -2. -3 times 0 is 0, plus -2 is the same thing as subtracting 2. 0 minus 2, I know, is -2. And I'm left with -2 equals -2. That is true. So on your own, go ahead and substitute 1, 1 and 2, 4 into the equation we started with, and make sure those solutions are true. Alright, every time I ended up with a true statement, hopefully you ended up with a true statement as well. So that tells me that my answer is correct. And just as a reminder, our answer is these 3 solutions: 2, 4, 1, 1, and 0, -2. Those are 3 solutions to the curve -3x plus y equals -2, or to the curve y equals 3x minus 2. So one way we can do this is by graphing. Another way we can do it is by creating a table, and that's going to be our second and final example. So now we are identifying solutions from a table, and we are going to use the curve y equals 3 to the power of x. So first thing is to make sure we've solved for y. Same step that we took with finding solutions by graphing. Well, in this case, where we have y equals 3 to the power of x, we have already solved for y. Y is the only thing alone. So we can skip the first step and move on to step 2. Create a table by selecting 3 x values. So here is my table, and I am going to select the values of 0, 1, and 2. You can select any x values you want, but I'm selecting those because I think it's easier to stick with smaller numbers. Now, to finish creating the table, we need to substitute each of those back into our original equation. So I'm going to start out with y equals 3 to the power of 0, which means y equals 1. Next we have y equals 3 to the power of 1. 3 to the power of 1 is 3. So if x equals 1, y equals 3. And finally we have y equals 3 to the power of 2, which leaves me with y equals 9. So when x equals 2, y equals 9. The next thing I'm going to do is identify 3 solutions, just like I identified 3 solutions from the graph. So let's go ahead and erase this work below and then write our 3 solutions. Our first solution was 0, 1. The second solution was 1, 3. And the third solution was 2, 9. You'll notice that the steps from identifying solutions from a table are very similar to the identifying solutions from our graph. So we solved for y, we created the table or the graph, we identified 3 solutions, and then step 4, once again, is going to be to prove the solutions are true. So once again, let's take that first point, 0, 1, and let's plug it into y equals 3 to the power of x. So in place of y, we have a 1. In place of x, we have a 0. And I know that any number to the power of 0 always equals 1. So I'm left with 1 equals 1, which is true. Now go ahead and substitute 1, 3 and substitute 2, 9 and see if you get the same solution, or true solutions. So I came up with 3 equals 3 to the power of 1, which is 3 equals 3. That's a true statement. And 9 equals 3 squared, or 9 equals 9, which is also a true statement. So it is safe to say that 0, 1, 1, 3, and 2, 9 are all solutions of the curve y equals 3 to the power of x.